I'm at the compressors right now.
Which compressor is running?
Bravo.
Go ahead, Beal.
From here, as I mentioned, everything that we do is monitored and or controlled from here. It's a very state-of-the-art automated system. All the latest technology for instrumentation and controls is what we use to produce our efficient and safe energy. We're controlling 2 gas turbines and a steam turbine, and then all of the supporting equipment is also controlled from here. From here, what you can see is our storage tank for our aqueous ammonia that we use for emissions control. That's 19% ammonia, and that reacting with our NOx emissions converts that chemically to non-pollutant emissions, primarily water vapor and nitrogen gas. Looking over this way, we'll see the primary cooling tower. From here, we take our water out of the Monongahela River. We process it in the area here to the left, and with that we have a clarifier filtration system that removes any solids that are in the water to make it better and cleaner for our cooling tower so that we don't get any solids deposits in the system. We have mechanical fans on top of the cooling tower which draw air up through the water to cool it off. Then that cold water goes to the condenser that we'll see later that converts the steam back to water that we can put back to the boilers. The combined cycle process that we operate starts with consumption of gas in 2 General Electric gas turbines. The exhaust off of those gas turbines comes out at about 1100 degrees Fahrenheit. That hot gas comes into our heat recovery steam generator, which is primarily basically a giant boiler. It uses all that thermal energy coming off of the gas turbines to convert water to steam. And then at the stack exhaust, our temperature is approximately 170 to 180 degrees. So the steam that's generated in our heat recovery steam generator, that is used in our steam turbine to produce additional power. Next, we'll move over closer to the cooling tower and let you get a better look at that. As I mentioned before, we do take our water from the Monongahela River. We run it through a clarification process and then filter it. And you can see those units, the solids that we remove from the water then get pressed hydraulically and hauled away to a landfill as dirt that they use for cover. This is our transmission switchyard. From here, our generators produce our electricity at 18,000 volts. These main transformers that you see here convert that 18,000 volts to 525,000 volts. And that's what we connect to the power system at, is 525,000 volts. The reason we step it up to that high of a voltage is that it's more efficient for the transmission lines. So the higher your volts are, the lower your current is, so you have less thermal loss in the transmission line. We produce 620 megawatts is what our nominal rating is. 620 megawatts would power about 500,000 normal homes. We're going to go in the building now and we'll see the steam turbine and the condenser. The gray box you see here is the condenser. That's what takes the exhaust from the steam turbine that we'll see next and converts it back to water. Our steam turbine takes 3 different pressures of steam from the boilers. We have a high pressure, an intermediate, and a low pressure steam system. And those 3 pressures combined drive the steam turbine, which produces about 300 megawatts, a little over 300 megawatts. If we were a what's called simple cycle plant, the exhaust of the gas turbine would go straight out the stack and would not have the efficiency that we have by driving a steam turbine. We're looking at 2 gas turbines here. Gas turbine 1 is closest to us, gas turbine 2 is behind it. Each of those consumes natural gas to burn and produce power. Each of those generates about 170 megawatts. This is our chemistry lab. We do chemistry twice a day with manual samples that the operators collect. Everything that we do for our water chemistry preserves the life of the power plant, so we are very focused on it. We have online instrumentation that you can see here, as well as the manual samples that the operators do to validate the instruments that are constantly reporting back to the control room. These are our 2 boiler feed water pumps. Each one of our boiler has 2 primary feed water pumps that deliver the water to the high pressure and intermediate pressure sections. The low pressure section has its source water from the condenser. We have condensate pumps over there that put it to the low pressure drum. Then these pumps take suction off of the low pressure drum and move it to the other 2 areas for the boiler. And these 3 units on this side are the inlet chillers. They have massive air conditioning compressors on the inside, as well as a condenser on top of each unit for cooling. This is where the fuel gas comes into our facility. We get our gas from Spectra Energy. They're a natural gas provider for us. It comes through the moisture separators that you see, and from there it goes underground and splits out to go to all the different places in the plant that we use natural gas, including the gas turbines, the building heat, the duct burners, and all of those things. That pretty much covers it. We've seen everything from the water treatment part of the facility, where really the life starts of a power plant, through the coolant tower, the switch yard, the different turbines and condenser that we have. We've seen the boilers and where the emissions control is done. We've seen the fuel source and our inlet chillers and duct burners, and I think that pretty much summarizes how a combined cycle power plant like ours operates.